Welcome to Neutral Podcast, where we discuss paving the way to a regenerative tomorrow. I'm Nate Helbach, your host, founder, and CEO of Neutral, a regenerative real estate development company. Join us each week as we host world-renowned guests and explore the dynamic landscapes of real estate development, alternative investing, sustainability, forestry, urbanism, and design. Learning how to make places for people. Welcome back to Neutral Podcast. Today we're joined by Daryl Patterson, and we have the privilege to speak about innovation in construction and sustainable development. Daryl brings nearly 3 decades of expertise from his tenure at Lendlease, where he was most recently serving as Chief Product Officer and Head of Design for Lendlease during his tenure, which ended in 2022. Throughout his distinguished career, Daryl has established himself as a pioneer force in construction technology and sustainable building practices. His achievements include introducing cross-laminated timber, otherwise known as CLT, to the Australian market, and establishing the foundational research framework for Building 4.0, Australia's premier construction research initiative. Currently, Daryl is leading significant research at Monash University in Melbourne, focusing on advancing manufacturing techniques for multi-story buildings. His work continues to shape the intersection of technology, sustainability, and practical construction methodologies, which we'll be talking about a lot today, which I'm excited to get into. And maybe, Daryl, one thing that you could just give us some background on to start us off with is just really, how did you get into this kind of large space of construction, and what does your personal and professional background look like?
Thanks, Nate, and thanks for the opportunity to be here and the really impressive welcome. I need you writing my CV on LinkedIn. It's great. So look, my background, I grew up in New Zealand, in a small city in the north of New Zealand, and came from a whole family of people who made things, right? It was just what was normally done. If you needed something, you made it. If it broke, you fixed it. And with grandfathers and parents and cousins and brothers, everybody had that same sort of behavior that you just got on and made stuff. And I thought that was normal, and maybe a couple of generations back, it probably was more normal that many people were hands-on doing things like that, but I think it's far less normal today. Perhaps one of the things that really changed the direction of my life is when I was sort of probably about 12 or 13, my parents built a new house, and they made the decision to use a contractor and not do it themselves, and they also used an architect. And so for the first time in my life, I saw these really bizarre, huge sheets of drawings with all of this arcane information on them. And I was fascinated by them. And I can remember poring all over those drawings, the old ammonia print drawings, which smelt terrible and highly toxic to handle, but, it was an incredible experience. I was fascinated by how you create this information set that someone could then turn into physical fabric. And it was probably influential, years later when I finished high school. I went and studied in Auckland and completed a degree in architecture. And that was a pretty conventional training process, I guess. In the final year of that degree back then, there was always an option to complete a major design project or to write a design thesis. And I thought, well, I'll take the path less chosen. I'll write the design thesis. And if you've ever written a thesis, you know what happens. You sort of hibernate in a cave for 6 months and you hammer away at a keyboard trying to complete one of these things. And I remember finishing that, handing in this thesis, and buying a cup of coffee and a newspaper and unfolding this newspaper to this front page story that told the news of the largest architectural firm in the country. Its principal had closed the doors and he was driving a cab to feed his family. The economy had reached that point. And I thought, well, this is probably not the best time to be graduating in architecture with a whole lot of student debt. And fortunately, a few days later, a friend rang and said, hey, he's working for a construction company. Would I like to get a role in construction management? And I said, well, not really, but, it sounds like probably a sensible choice. And I thought, well, I'll take that job and I'll do it for a couple of years and we'll see where the economy ends up after that. And then I'll go back into this thing I've always wanted to do, which was be an architect. Turned out that construction business was a division of the global Lendlease Corporation. And the more I learned about the company, the more fascinated I was, right? They had this tremendous, rich history from the 1950s onwards of innovation. They were in all kinds of different businesses, which were really diverse, everything from insurance and funds management to property development, design and construction. And it was just an incredible collection of people with a really amazing attitude about, there was kind of no problem too big to solve. You could break things down. You could figure out how to do it. You could really question the way things were done, and you could find a better way to do it. So 2 years became 29, as they do. And it was a career of everything from the most junior role possible in a construction team to, as you mentioned, the chief product role at the end of the day. But I spent a very large chunk of that time in property development, nearly 20 years, across the development and construction of a very large number of residential properties, mainly high-rise apartments, mainly at the luxury end of the market, to be fair. And I also spent half that time really focused not working in the business, but working on the business. And so really trying to understand, how do we become more efficient, more productive? How do we become more competitive? How do we increase, the throughput through the business? What can we do about quality, which is a sort of eternal challenge in construction? And I had the immense privilege throughout that 15 years of doing that kind of work, firstly, to be given a lot of latitude to try different things. Secondly, to work with some incredible people all around the world. And we did try an enormous number of different things, and we had a lot of success. Some things were tremendously successful, and other things weren't, right? And we learned from the successes and the failures. And I've talked publicly about quite a few of the failures. I've probably talked less about the success. But eventually where we got to was really deeply in the space that, you've done a lot of work in and you're talking a lot about, which is industrialized construction and its intersection with digital technologies and in particular things like mass timber. So that's kind of, 30 years in 3 minutes.
Thanks for the background, Daryl. I think one thing you touched on, which is really interesting, is you growing up when you were 13 and your parents building a home, and this kind of information transfer of taking an architectural set and seeing it come to life in a building. How did that kind of affect the way you have looked at, like, hey, we have all these drawings, all these lines on paper that are eventually going to become walls and bathrooms and sinks? And how does that kind of affect the way you view this idea of kind of industrialization in the modern world now that we're 30 years or 20 years past that?
Yeah, it's a good question. I think there are a couple of consequences of it. One is I went off with a very naive misunderstanding that there was this tight nexus between design and making. And of course, the longer you spend in the industry, the more you find out that the nexus is somewhat broken, and it seems to be getting worse, right? The people who do design work are not necessarily particularly well connected to those who do the making work, and they don't understand each other's processes. The information doesn't transfer as well as it should. I think the other insight is that to describe even something as simple as a house with conventional drawings and text is pretty arduous, right? There's hundreds of pages of specification. There's lots of sheets of drawings. There's, tiny things like single dimensions that are very meaningful in the execution of the work. And so you've got this density of information, which you're hoping is going to get translated through some eyeballs into some hands out in the field by, people who may be in a hurry, may have misunderstood, may have other ideas of their own, and so you see that it's not as effective as it perhaps could be. And I think the problem's gotten worse over the last 25 years because those drawings that I'm talking about first seeing were hand-drawn. Maybe there were 20 sheets for a house. And now when we look at any project that's been, produced from BIM, we see thousands and thousands of drawings. So the pile of information has in fact gotten a lot worse. And yet we know we have this ability to transmit information in much more streamlined ways, right? Like sometimes it can go directly from designer to machine without passing through lots of sets of eyeballs and lots of translations. And it feels like we're still quite a long way from really exploiting different transfers of information the right way.
Yeah, that's the sense I get as well, is we've almost reverted back to even older methodologies than maybe what we were utilizing right at the turn of the century. I know at Lendlease, talking about this idea of like digitizing, you had a really kind of big emphasis on digitizing the supply chain, and you talked about it a little bit, but maybe give us more insight into how you kind of took the architect and engineer and took their plans and went right to basically fabrication, and you kind of took away the whole shop drawing review process.
Yeah, there was a piece of work we started doing back in 2016, myself and a couple of other collaborators, and we'd all been in the industry for a while, and we sort of observed that there was software for every different role in the industry. Architects had their software, engineers had theirs, construction guys had theirs. What we couldn't see was any kind of commonality, any platform that connected all these players together. And so you had software that had been designed to help a designer, but it didn't help someone understand cost or schedule. And the software that did those things didn't connect to design software. So we thought, well, there has to be value in the notion of a platform that brought the entire value chain together, that connected all stakeholders. And yeah, they'd still need their own apps and work in their own space, but there had to be a core of connectivity between them. And that's what we started sketching up, back then. And we figured that this core probably needed to be represented by something like a digital twin. So we did a lot of work around digital twins. The challenge we found, though, with digital twins is they're very, very labor intensive to create. You can draw your way to a digital twin, but, chances are by the time you've done that, the project is, built and done and no one's interested. So that led us into a space of automating design, right? And we didn't start design automation because we went, oh, look, designers don't do a good job and we should automate them away. We did it because we could see that design shouldn't automate to the level of concept. We believe that should automate to the level where a machine can pick up the information and cut the part or make the thing that needed to be made. So to get that level of fabrication design information, design automation looked like an interesting path. At the same time, I was really interested in industrialized construction, particularly in the mass timber space, and the idea that more and more building fabric could become made from pieces that were produced off-site, and potentially that production method was also digital. And so we fused the two ideas together, this design automation to get to digital twins with industrialized sets of parts, essentially, and kind of helped the automation because we'd seen a lot of design automation happening, which was trying to work without any kind of notion of what the material the building was to be made of, or who was going to make it, or where it was going to be supplied from. And it looked trying to solve an infinite problem, right? And we figured if you could start with, specific components, supply chains, and actually know that this nut and bolt or this beam or column or whatever it was this thing at this price point, available from this party, you had a much more manageable solution space to automate within. And we did a lot of work on that. We ended up building some pretty interesting design tools that we weren't really interested in simple parametric tools. We wanted to be able to encode the logic of design at sort of first principles. So how does the structure work? What are the physics we're taking into account here? How do we calculate load paths and contributory loads? And so we built a lot of capability around that to get to an LOD 450 level of output to say, okay, that's ready to buy, it's ready to make, it's ready to ship. And obviously one of the values of doing something like that is you start to get real-time feedback on your design decisions. It's like, the building's going to cost this, it's going to have this carbon footprint, right? And you can therefore make a change in your design direction before you go too far, before you fossilize all those design decisions that you don't want to unwind later on when you finally get a cost, when you finally get a carbon analysis, or you finally get feedback on regulations. So it was, it was really interesting work. It's still going on. There's still a product in market that team has delivered. It's a much, much smaller part of what the original platform was envisaged as being. But that's inevitable because you can sketch out these grand platforms, but you've eventually got to, hone down and isolate on pieces of them.
Yeah. So it seems to me, and the product you're talking about, just for reference for the audience, is called Podium, correct?
That's right. Yeah.
And it seems to me that Lendlease kind of developed this concept of Podium as this kind of comprehensive digital integration solution that would kind of integrate all these different aspects of construction into one space. Is that a correct interpretation?
Yeah, that's fair. Yeah.
And how did you see, like, after you build Podium, or at least the kind of MVP, minimal viable product number one, how is that platform helping you kind of fundamentally, or maybe not helping you because you were working on the business, for those that were working in the business, how is it helping those people go through their process of development or construction or design more smoothly or quickly? Or like, what were the KPIs that you guys set up that said, if Podium did this, it was successful?
Yeah. So one of the places we saw it having early impact was when people are trying to acquire new land and you don't know what you're going to build on it, right? It's literally it's a blank slate. Maybe you're bidding for that land competitively in a tight time frame. Maybe you have to make an offer, but you want to form a view pretty rapidly on what will be successful there, what will meet market requirements, regulatory requirements, and what will return a profit, because it's a for-profit business. So a tool that could let you iterate through design scenarios that were real in terms of, they were buildable, they were costed, completely viable outcomes. A tool that could let you do that in minutes, literally in 2 to 3 minutes, to explore one scheme and then go explore another and another and another. That is something of a game changer. And there's other products coming to market now that are similar, but I think what I haven't seen yet is people trying to get that kind of later stage information, right? Like, what is the actual material that's going to go into the structure of this building that we're just doing early feasibility analysis of, right? So it was sort of more holistic in that way. What I didn't see before I left the business was how it went the life of the project. So having, conceptualized a scheme that way, did you continue on to execute it using that design and that tool? That's definitely the intent of the platform, but I'd left the business before the MVP was capable of really going the life of a project.
Yeah, because sounds very similar to what we're building in Neutral, and we've kind of gotten past the stage of conceptualization and kind of feasibility, we'll call it, and are now in the stage of like execution and delivery. And it seems to me like the feasibility and conceptualization is a very not rudimentary, like there's a lot of kind of initial formulas you want there, a lot of logic that you want in that stage to make your execution delivery stage. But I think we're running into a lot more roadblocks, it feels like, in the execution and delivery stage, mostly from like this idea of how do you take these kind of drawings that you have that work financially, right? Like you're narrowing your problem sets down to sites that work financially and are maybe in a relatively good order. Like you have all square sites that will work for your system. But how do you take that to the next stage of like, okay, now we actually have to put, and it sounds like you guys did a lot of this, like plans together for LOD 400 or LOD 500, whatever the fabricator needs, to be able to say, okay, press print, and it goes to the offsite manufacturer to start making the components. Like, how did you kind of bridge that gap?
Well, that is the complexity of it. It's the art of it. I think, one way we see a lot of people trying to do it is that they simply have a large object library of predetermined solutions. And I think that's probably the easiest way to do it. We were trying to do it by a much more complex method where we wanted a lot of the parts to generate, right? And we wanted them all to generate, as I said, from really first principle analysis. Like the timber column in the building, let its size generate from, the load analysis that the scheme is producing, and then let it match that load analysis to the nearest market available size column, right? So obviously you didn't want to produce a column that had to be custom fabricated. You wanted to produce a column that someone made. And so it had to kind of look up a table of solutions once it had predetermined the minimum capacity. But then it would go on and do other things. So for example, the column's one part, but the connection between the column and the next column is critical. So it had to size a connector, right? It had to look for the amount of kilonewtons that the connection had to handle. And it could do another step there where it could say, well, okay, there's 5 different connectors available in market that will handle the loads, and they have been physically sized to fit the column. But which one is more cost effective? Because this one is $500 and this one is $1,000. And so it could then choose based on a second series of goals, if you like, to seek for. And it didn't need to be cost. It could have been other things. It could have been, what was the install speed, right? We're interested in a project that goes up very fast. So I'm less concerned about the cost per connector, but can I put it together in a minute or two versus an hour or two? So that kind of multi-goal seeking generative approach is what we were trying to do. It worked pretty well in structure, right? We were only really adding all the other design disciplines to it as I left. So the question the team had to address was, could you continue that complex multi-goal solving as you layered in all of the design disciplines, or did it eventually become too complex? And
yeah,
on that.
Yeah, because it seems like the structure, I mean, is huge, right? That's your primary element, and a lot of cost is stored there. So that's a huge accomplishment. But then taking it one step further, it seems like the goal seek calculation and methodology you guys were doing is amazing, but the computation needed to do that for every aspect of the building would be like unbelievable computation, to the point where you have this almost paradox of choice problem of like, you're going to run into, okay, you have 8 connectors, 2 are $500, one maybe sources in 6 months, the other sources in 7 months. What one do we pick? I don't know. Right. And so I'm wondering, do you think, like, retrospectively looking back at it, if you're starting to apply this kind of very granular computation methodology with goal seek for each component, do you think that's the most kind of quickest way to market for something that you want as a configurator to go from feasibility through execution and delivery? Or do you think it's like, do you narrow your problem set down, define it, and then maybe from that narrow problem set expand as you do more and more projects and get more and more data?
Oh, it's unquestionably the latter, right? Like what we were trying to do, while it was sort of beautiful, it was also, overwhelmingly complex. And we did have a massive amount of philosophical debate. Do you produce a huge solution set and then filter it through analysis, or do you perfectly goal seek to the one solution that is the best solution? And the purists always want to do that. They want to, compute their way to the perfect solution, and they want to do that really quickly. But it's exactly what you said. It's computational, ridiculously heavy computationally. And then, you see in the sort of goals that you're seeking, every customer or client has a different mindset about prioritization. So then you start building interfaces where you can manipulate all of these goals, and it's a complex product. If you want to get going, you don't need to do any of this, right? You need to just figure out your catalog of your parts, figure out the sensible parameters around those that you're interested in, whether it's cost or carbon or whatever it is, and then build a basic configurator and start. I think, if we were doing it over again, we would probably focus on MVPs like that. If you wanted the really sophisticated first principle stuff happening, maybe that's another team in a corner that can have the luxury of a long period of time to work their way through it, but it's not quick, it's not cheap.
Yeah. No, I think this is a good transition into our next segment about modular, and we'll come back to this idea about digitizing the construction workflows. But I think one thing that I've seen is like a lot of modular companies have raised a lot of VC capital with this idea that, and I think it's a great idea, so don't get me wrong when I say this, but it's this kind of ivory tower idea that once you create this kind of digitized platform, you can then go and actually make these modular buildings, right? And I think that that's really, really nice to say on a pitch deck and really great in theory. But a lot of developers and builders have attempted to do this and have failed. And I think there's like this kind of graveyard, unfortunately, of like the Kateras, the Vives, the factory OS of the world that have gone to market and raised hundreds of millions of dollars and said, hey, I'm gonna do this thing that we're gonna call as modular or componentized, and haven't been able to do it. So where do you think like the failures are derived from?
Well, I mean, there's lots of reasons for failure, but I think there's three big ones that we can see again and again if we start analyzing, not just the most recent high-profile failures, but maybe the last century of effort in the whole offsite fabrication industry, which has just kind of been accelerated by what's happening recently in digital. I think the first one is focus, right? Which is kind of thematically what we were just covering, that almost all of these companies expand their remit rapidly with good intentions. Like they need to build a digital tool. They need to figure out their physical parts and solutions. They want to do a residential building. They want to do an office building. They want to do a hotel. They want to do a healthcare building, and they want to operate in this country and that country and 20 different jurisdictions. And, we've seen some of these companies selling everything from buildings to technology that allows the occupant to control the air conditioning. There is just a lack of focus here. And, people say, well, it's a bit like trying to eat an elephant. I said, no, it's not like trying to eat an elephant. It's like trying to eat an entire herd of elephants, and they're not standing still while you're trying to eat them. They're stampeding, right? So you better just pick one. And most of these companies have really failed to do that. And in a sense, the work I was leading, there was some failure to do that. We needed to really, hone down to a tight focus. So tight, right? Maybe it's even just getting a few building pieces figured out and deployed into construction, which is largely traditional as a starting place. I think the second thing, which is massive, and I just hear it all the time, whether it's a heavily funded venture or whether it's a bootstrap thing, we're going to build a factory and it's going to be amazing, and we're just going to, kill the market. We're going to be great. It's this over dependency on the idea of the factory. And you go, well, what's that about? Oh, well, factories are efficient. It doesn't rain in a factory like it does in the field, right? We can get so much more done. And then the next part of that statement is, and we've got this great equipment, right? We've bought robots or whatever we've got. And it's true. Factories are efficient, right? And it doesn't rain in factories. But the reality is they have other inefficiencies. For example, you now have two different workplaces. You have a construction site and a factory, which implies you have two management teams, and you have another layer of transport and logistics between the two locations. And so, when you add it all up, just having a factory, what that usually means is it comes out a wash, right? So, all your efficiencies were offset by the cost of having the factory. And at best, you're line ball competing with traditional construction. And if you offer the market something which is the same price as traditional, they'll take traditional, right? Because they know it, they trust it, and they're not getting confused by whatever you're talking about. I think the third thing, though, is a more insidious problem that doesn't get enough focus. It seems like good business practice to meet the market where it is, right? You hear that phrase all the time. You're going to produce a new product or service, create a new business. You should try and meet the market where it is because that, the customers are there. The problem with that is the customers out in the construction world today expect all this customization. This building is different from every other building ever executed. And, we're busy paying designers to do that. And if you try to spin up one of these offsite production facilities to do that customization, there's kind of very limited chance you're going to make any money out of it. And I think almost every one of these businesses I've seen is talking customization from day one. It's like, we will make whatever a client wants us to make. And if you drill into that, you go, I don't understand where you're generating any kind of efficiency in labor or materials. There's no economic impact of what you're doing because you're just shifting the work from place A to place B. So I think the last one, needs a lot more discussion and thinking, that simply doing customized buildings in a factory isn't really going to pay any way forward.
Yeah. If I can summarize those. So it's failure, which is leading to a lack of focus, factory, which is leading to a lack of efficiency, and then customization, which is leading to a lack of really just understanding holistically the supply chain and being able to create a manufacturing process that's almost similar to and akin to like a car manufacturer, right? Because like if you just look at manufacturing as a business regardless of building a building or building a car or building even like your nice little grocery store box, right? Like everything with manufacturing has to be consistent. And so, as you said, right now in the building space, nothing's consistent. Everything is customized. And that's the sense I get, is like, I think that's the number one failure for a lot of these firms, because lack of focus, you can get around by just making more money. Factory inefficiencies, you can get around by pushing more things through the factory that are the same. But if you can never create a process within your factory that's consistent, it's like that's not going to lead to success, because factories are made to make the same thing over and over again. And I think that's the big issue that a lot of these modular companies have, which has led to their failures, which I'm curious, what do you think the solution is, if any? Like, is this even a good business model?
Well, we're saying the same thing essentially. So, standardization is pretty critical. If we look at the factory system that evolved out of the Industrial Revolution, and which is now the advanced manufacturing, which makes pretty much every product in our lives other than buildings, right? It's not about the factory, it's about the product that goes through the factory, right? And people talk about economies of scale. Well, it's really economies of learning, right? It's, if I make something over and over again, if I do anything over and over again, I get very good at it, right? That's how sports teams win, right? They practice. And it's the same in manufacturing. If you set a business the challenge to make something thousands of times over, they will find the shortcuts, the efficiencies, the way to do things faster and cheaper, and most importantly, they'll find the ways to do it better, right? So I think inevitably what you've got to do is figure out how you can standardize and productize more and more of the building fabric. And the challenge in that, and people get a bit excited about it, it's like you don't need to standardize an entire building, right? And you perhaps don't even need to standardize more than 80% of it. And you've got to allow for some flexibility, that every parcel of land and every jurisdiction will be somewhat different. And so you've got to figure out what that 80% is that should be standardized rather than the 100%. And that's a different mindset, I think, from a lot of the factories that have been set up to say, the goal is take all of the work off site. I don't think that's the goal at all. I think the goal is to figure out which piece of the building fabric should be productized and repeated, so that you're getting maximum efficiency from the engineering and design effort that went into that product. And you've got this cycle of learning where you continually improve.
And how do you think, like, if there's a new, let's just say, modular manufacturer that comes about in the next 2 years, it seems like there's no demand for that type of design, right? Because things in the building industry really haven't changed from this idea of customization ever, right? Things are still customized. So how do you think they generate enough demand to suffice that type of business model?
Yeah, and we might get into the language in a bit about what we mean by modular versus other solutions. But, let's just say it's any pre-manufactured thing, whether it's a kit of parts or a volumetric module. I think the first challenge you see is most of the industry is not offering a standard. Like, if you go to the bathroom pod makers around the world, they're waiting for the project team to tell them the design of the bathroom, and then they'll respond with, a shop design for that bathroom, and they'll fabricate it. They don't sit there with a standard bathroom saying, here's model A or B or C, right? They're not selling that. They're selling a custom service. So the first thing is someone's got to turn that around and say, no, I'm going to sell a standard product. But to make that compelling, they've got to offer the cost benefit of that. Like if you were offered 2 bathroom types, if you were a developer of, condos or build to rent product, and someone said, oh, look, we'll build your custom bathroom for $35,000 a bathroom, or you can have exactly the same size bathroom with the same quality of fixtures and finishes in it, but it's going to be $7,000 cheaper. I think most clients would be seriously interested in the product that's 20% cheaper, right? But I don't see anyone making that offer today, right? I don't see anyone with that standard product, and I don't see anyone offering that cost delta. Is that cost delta possible? Well, when I talk to bathroom pod manufacturers here in Australia, without really pushing them on it, if you make a comment like, well, what if this entire pipeline from this client was standardized? The reaction is, oh, we could cut the price 20% straight away, right? So that would be my advice to anyone trying to spin up a new business in the sector, is maybe instead of trying to meet the market and customize a response, maybe think about putting some standard products with a big cost delta against them in there that, customers can rely upon.
Yeah. No, I think that's good advice. One thing I wanted to touch on, just so we can kind of differentiate these two terms, is volumetric modular and componentization. In your mind, what's kind of the difference between the two?
If the module is obviously the fully finished box, or it's the six-sided thing that's coming from somewhere with a high degree of finishing in it. And there's a lot of that going on around the world. It's almost like it's the first idea everybody has with some sort of prefabricated approach. Make a box, fit it out. Hey, look how amazing this is. It has the entire bathroom already installed in it. And technically you can do all of that. The componentized approach is to say, well, we're not trying to shift all of the work from the construction site. We're trying to send the construction site pieces that will assemble quite rapidly. They don't have to do any traditional construction work to assemble the pieces. They might just clip them together or bolt them together. But they might have wall panels or floor panels or cassettes or modules of things that rapidly assemble. And there's a big difference between the two approaches, right? The first approach is really just shift all the labor, right? Take it all away from the site and put it somewhere else. And it comes with some constraints, right? When you think about a module that's going to a site, the key constraint is always the truck that it goes on. So you have a module whose dimensions are governed by the trailer behind the truck and whatever the local regulations are about load widths. So that would be okay, except when you look at most trailer dimensions and compare it to most spaces that we plan in buildings, particularly residential, the compatibility is quite low, right? The widths of those modules tend to be on the very narrow side compared to where we would like them. The second thing is, by virtue of that box, you've implemented a grid, if you like, or a module, if you like, into the design, which is somewhat inflexible, right? It's not impossible. It works really well for some building typologies. I think hotels are an example of it working pretty well. So I'm not saying it's a bad idea. It's just it has certain constraints that, we need to be aware of. Whereas in the parts approach, it tends to be more flexible, right? It's easier to put a trailer load of floor panels together on a truck and not be constrained by the width of the truck deck. You might stand them vertically instead. So flexibility in design is one of the big differences between those two systems. The trade-off on where all the labor will be is obviously another one. So where full volumetric is super appealing is if you're trying to construct something where there's no labor, right? In Australia, the examples would be, resorts on offshore islands or mining camps where in the outback where there's no labor. You've got no choice. You're best building in the metro area and trucking the entire completed assembly. If you don't have those kind of conditions, then my leaning is toward the greater flexibility of the parts. But then there's a secondary issue I want to talk about, which is back to this idea of products and repeatability. If you think about a major tower, it might have 200 boxes in it if you do it with a volumetric assembly. Okay, 200 boxes, that's a part count. But if you did it out of flat pack kit set parts, that might be more like, it's 3,000-4,000 pieces. And those parts have a greater repeatability between multiple projects. And so then you start getting those economies of learning, right? That the modules don't have the same ability to generate. So I think in the long term, really the parts approach feels like it's got more value to capture in the manufacturing process.
Yeah, that's my sense as well, especially when you look at like flat packed componentized parts. I mean, if you just look at one aspect of it alone, the shipping, the cost of shipping a big volumetric modular component is so expensive, especially when you're talking about these huge oversized loads in the US and getting that halfway across the country or all the way across the country if the manufacturer's in New York and you're building in California. But I think with the componentization, that's where it makes a lot of sense because it's just like shipping anything else, right? We've been doing it for centuries with other materials. And so it's like, why can't we do it with building materials? And yeah, I think there's a lot of pros to the flat pack and a lot of cons, it feels like. And it doesn't seem obvious to me that there's a lot of pros for volumetric modular unless you have these specific use cases like you talked about in the Outback or on.
Yeah, I think the one qualifier I'd put in there is, we often talk about full volumetric. I think if you're talking about doing volumetric bathroom pods or maybe a service module of some sort, there's merit in that, right? Because what you're doing is you're concentrating complexity. Like a bathroom is a very complex thing when you look at it. It's got it's got a lot of services, it's got a lot of complex finishes, it's got waterproofing and other things which have to be done with care and attention. And so there is some merit in concentrating that complexity and transporting that potentially as an assembly. It's not the only way you can do it, but that would be the one counterpoint. But if you're trying to transport a whole bedroom or a whole living room, these are very simple spaces, right? They're just air mainly. And to your point, why are you spending huge amounts of money transporting boxes of air?
Yeah. I think we're starting to look into that. I mean, we're taking the more, I'll say, traditional approach and adding aspects of componentization to it. And for our next project, we're looking at what we're calling an MEP prefab modular component, which basically has your MEP run all in one centralized spot that's done off site and then shipped to site. And it's basically like almost, you can think about it as like the engine of the building outside of the structure that's kind of allowing you to power everything and distribute everything from this one centralized spot. Which I think in that use case, it makes a lot of sense to do volumetric modular offsite, allow the MEP guys to work in a enclosed environment, very easy, and then ship everything pre-assembled to site. But outside of that, it doesn't seem like super apparent to me there's a lot of other components you would want to do that with.
No, I agree. I think the MEP space is a really interesting one to examine. If you think about what happens in most traditional construction, the MEP workers are the people up the ladders and on the platforms, right? Installing work above their head, which we know is the least ergonomic position a human being can actually work in, right? Once you're stretching your arms above your shoulder, you get tired quickly. It's bad for you. Your productivity is very low. And yet those are pretty much our most expensive trades that we put into that situation. We ask them to do all their work hanging off the underside of the slab. It's anything that changes that equation, right? That moves that work into an ergonomic setting. So it can be done by the same people, but it can be done way more efficiently because it's at workbench height or it's inverted so that they're working with gravity, helping them rather than fighting them. And I think you're right. If you can then take that work, bundle it up and send it, maybe that's a small module of some sort, that makes tremendous sense to me.
Yeah. It'll be interesting to see if we can pull it off, but I think the idea is really good. All right, transitioning, because I know we're about out on time, but transitioning to our last segment here, one area and material that I think has done this actually really well, which you were instrumental in bringing to Australia, which is mass timber. Which it kind of has these already inherent properties of precision and prefabrication kind of really made into the product type because it's a fabricated wood material with pretty much dimensional stability. How do you see that kind of affecting this idea of componentization in Australia and kind of across the US?
Yeah, well, I think firstly, with any kind of approach on componentization, what you're actually doing is you're taking apart the concepts of how a building's made, you're re-examining it, and you're putting it back together into new ways, right? New layers of materials, new assemblies. And it's a really interesting and rewarding exercise to do, is that kind of decoupling and recoupling of the building fabric as you think about what might be possible when you're not making things in a traditional sequence. And so, when you first explore mass timber and you go see one of these mass timber buildings at some stage in its construction, a lot of people fall in love with it, right? Even if they've got no sort of prior experience of working with timber before. And there's a lot of reasons that you want to love it, right? Wonderfully clean work sites without all of the noise and dust and waste, a material that's really workable, right? You can drill into it, you can cut it, you don't need, heavy duty equipment to be able to work with it like you might with steel or concrete. It's got a weight advantage. It's significantly lighter than concrete, and yet you can get concrete style structures out of the material without the weight penalty. And it just goes on, right? You've got a natural organic material, and turns out humans have an affinity for being surrounded by natural materials, right? We somehow kind of prefer it to being surrounded by totally artificial products. And then you get to the carbon story, right? And that's reasonably obvious for most people, that you've got a renewable material that is capturing carbon, and you can come up with end-of-life plans for, keeping these products in use for a long time and before you start downcycling them. So you've got this new material, or old material made new again by virtue of the engineering thinking that's gone into how it's laminated. And what we have to do is really re-examine how we use that material in building fabric. And the first buildings I did with it, we were just sort of directly substituting, concrete for mass timber for concrete. And it was the same kind of design logic and building assembly logic. And I think what you start realizing is, no, there's more prefabrication opportunity here because it's lighter. I can get more of the stuff on a truck. There's more value add opportunity. I can put connectors on the material before I send the thing to site. I might put surfaces on the material. I could use the floor panels as skids essentially to deliver the services on them. I could even pre-finish them and wrap them with, whatever the final finish is for the building. And it's this sort of discovery we're in at the moment, I think, about how we can use this lighter weight natural material to enable this different packaging of solutions to be delivered to the site. The accuracy piece is really interesting. So, if you're used to conventional construction in the field with concrete, I don't know the US standards, but in Australia, basically it can be plus or minus an inch, and it's still conforming with the standards. It's still perfectly okay. But if you're trying to fit precise fabricated pieces like a kitchen between two concrete columns, which each one can vary by an inch, pretty disastrous. So of course we deal with that with makeup pieces and with site measures and all kinds of really inefficient work. And we get into this timber space, and now the plus or minus an inch has become plus or minus an eighth of an inch, really not based on the fabrication of the material, but just how accurately the installer can place it. And we've seen them placed essentially perfectly, right? So seems like a small detail, but it totally transforms your ability to manufacture all the other parts of the building. It totally transforms the ability to fit things together with ease and efficiency, and not having a lot of, really time-consuming, frustrating processes like site measures. We're still figuring all that stuff out because even though you make a part to, very tight tolerances, in reality, when things are in the field, materials deflect. Dirt and contamination gets into fittings and fixtures, which compounds the ability to put them together. And so, it's not as simple as drawing something to great precision, manufacturing it to great precision. It will all happen magically at site. There's still a lot of thinking and learning to do about fit and finish of these pieces. But mass timber so far is a long way in front of a lot of other materials, including, steel.
Yeah, it seems like, to our earlier points about having a manufacturer basically give the market a product and say, buy this, and it's X price. I feel like mass timber manufacturers have done the best job of that to date, of really saying, like, here's our product, you can use it or don't, but we're not going to modify it or really customize it to a large extent. There's definitely customization within their parameters, but they're not really cowtailing to specific customizations of the market. And I think it seems like it's been successful for them. One question I had for you is kind of going back to where we started the call with how your work on Podium has really been affected by mass timber. How have you kind of seen this kind of convergence of digital design and mass timber happen within the framework of Podium?
Yeah, well, a bit like I was saying with digital twins, where they're labor intensive to generate them. I think, as fantastic as mass timber is, we ran our own processing factory for about 4 years. So we were importing a blank or raw product from Europe, and then we were cutting it to the requirements of a job. What you learn really quickly when you do that, the machines are awesome. They'll cut whatever you want them to cut. But you have to put a lot of effort into the design files that are going to instruct those machines. It's a huge amount of effort, right? You've got to create the tooling paths and the tooling strategies. And we assembled a really great team to do that work, right? Best in class people who did that all day long. But the more and more work you're trying to put through, you realize you're just trying to scale that team up to do more and more labor intensive design file creation. And so you go back to the design automation piece and say, I need to be able to feed basic shapes into some software and let the software generate all of the complexity and, from not just nesting of parts, but literally which tool will the machine pick up and at what speed will it operate it? And, is that the most efficient tool path that it can create, or is there a better one? And rather than be very limited in the number of resources you can throw that, I think that's where the intersection with digital is so important. You can take a CLT panel and you can cut it two different ways with two different tools. And one way might take you an hour and another way might take you 15 minutes. And if you think about factory throughput and cost of the part and cost of waste materials, this might double or triple the cost of the part. So, it's really important to get these strategies under control. And I think that's where digital tools have got a huge amount of potential to combine with that material and get us to ever more cost-effective solutions.
Yeah, that's interesting. Did you guys at Lendlease buy your own kind of fabrication facility where you were buying basically, it sounds like blanks, and then fabricating and doing all the CNC yourselves?
We stood up a fairly large facility to do that. We had some pretty comprehensive CNC capability. We also created the potential to do a lot of value add. So we had finishing lines where we could add plasterboard onto CLT panels in the factory. We could automate all that process. We could add windows, etc. We never actually did a lot of that. We had the capability for it, but we didn't use that. And variety of reasons for that, but it's kind of the crawl, walk, run, right? You've got to get the client and the design team comfortable with the idea of receiving, this building that's been made from timber. It's been made in a factory. And then later on, you've got to add to that the value-added layers where they also get comfortable. So we didn't quite get there on the value-added stuff, but we certainly processed a huge amount of mass timber and learned a lot about that.
Interesting. Yeah, that would be really cool if you got to that value add, but it's cool you even set that capability up for the future. Is Lendlease still using that, or have they got
that shut down? I think it's another issue we didn't really talk about with the economics of manufacturing, that we had a period there where we weren't seeing any mass timber buildings come along, and we also hadn't found that cost delta at that point in time because we hadn't really productized anything. We were really just doing a custom service. And so without a cost delta and without a committed pipeline of work, the accountants quickly decided, well, we'd rather sell this factory off than just mothball it and wait for the next job to come along. And that's a problem for a lot of these factories. So you've got to figure out a way of having a sort of base load that continually goes through these factories when there's peaks and troughs between projects coming along.
And did Lendlease ever consider just like saying, hey, we're going to create our own product type and have our development team build that product type and finance it ourselves so that the factory has enough work to continue to travel?
We definitely did. We just didn't get there fast enough. And that's an important lesson for me, that creating physical products is hard work. It's more intensive. Like if you want to design a bathroom, you can use it over and over again. It's actually harder work than just designing a bathroom to go build in a traditional way, because you're trying to build in all kinds of manufacturing constraints and efficiencies. You're trying to build in product range that will, solve a number of different building solutions. And so we realized we needed to have some standard products to feed that factory with. But the time it was taking us to evolve those standard products exceeded the kind of patience of our, financial decision makers. So the factory got exited before the products were ready to deploy.
Do you think if they would have gone that direction of making a product type in-house and just executing it to allow the factory to continue its kind of trajectory, it would work?
No doubt it would have worked. I think it could have ultimately been very, very successful. The factory itself was very well designed and set up, had all the right equipment. It was efficient in the way it ran. It needed a product. If the product had the time to evolve, iterate through a few versions of it, you start getting those significant cost savings coming out of that learning effect of the product, I think we would have had a game-changing result. Realistically, it was probably another 2 to 3 years of effort to get to that level of performance. And this is the issue with capital. It's not always that patient.
Yeah. Patient capital, that's the luxury, isn't it? Well, Daryl, thanks for coming on the show today. It was really informative. Really appreciate your insights. And hopefully your summer in Australia goes well while we painfully suffer through our nice dark winter here in the United States.
Yeah, well, thanks for the opportunity to be here. There's a lot of exciting stuff happening in this market in the space of industrialized construction. I think once we get through our holiday period in the middle of our summer, we'll see some interesting demonstration work start to come through, which is very much in the space of what we've been talking about.
Cool. Daryl, where could people find you if they want to look into maybe more of your work or contact you?
Easiest place is LinkedIn. I'm there. I trade as the West Island Studio, which is a little commentary about the North and South Island of New Zealand. We tend to occasionally refer to Australia as the West Island.
Nice. Okay, we'll link that in the show notes so people can find you on LinkedIn, but really appreciate you coming on today.
Thanks very much.
At Neutral, we transcend the conventional notion of merely minimizing harm. We embrace a regenerative philosophy, seeking to create buildings that begin to contribute to the health of our planet. Each project we build gets us one step closer to this commitment, a living embodiment of practices that replenish and restore. We'd like to thank you for being part of this conversation. For more information, visit our website at neutral.us. Thanks again for tuning in, and we'll see you next time on the Neutral Podcast.